Okay, folks, here we are, page 174, number 5. Okay, we got volume of milk. It's normally distributed, and it's got a mean we don't know, but it does have a standard deviation of 8. Now, we got 900 of these cartons, and it's found that 25 of them have more than 100 or 1,002 milliliters. Calculate the mean. Okay, so let's take a look at the information we've got, and let's put it in front of us. First, we can tell we've got a normal distribution, and we've got a mean we don't know, but we've got a standard deviation of 8, but really we need the variance, and we're writing it like this. Okay, so then let's take a look. What do we know about it being more than 101,002? Well, 225 out of 900, it happens. So that's 25%. So I know that when I have 1,002 milliliters, that 25% of it is above that, which also means that 75% of it is below that. So I can use that information because my z-tables go to the left and not to the right. If I find the probability, and now I'm going to use, well, first let's find the probability of x, and it's going to be less than 1,002. We know it's 0.75. So now let's standardize it. So it's going to be the probability of z, and that's going to be less than 1,002 minus mu, which we don't know, but we do know standard deviation is 8. And we know that's going to be 0.75. So now all we've got to do is find out what the table says 0.75. So I go to there and I look at the probability of 0.75. That's the closest one is going to be right here, 0.7486. That gives me 0.67. And I look over here and I need to add 14. Well, 13 is closest to it, so then I use the 4. So 0.674. Well, now all I got to do is multiply, and I get 1,002 minus mu is equal to 5.392. And then all I got to do is get the mu by itself, and then I'll find out that my mean is going to be 996.6 blah blah blah, and if I round it, it'll be 997. All right, that's that. Now let's take a look at the second part. 3 of the cartons are chosen. Calculate that exactly 2 of them are more than 1,002 milliliters. All right, well, we know 225 out of the 900 are more than that. So that's our probability. And then when we pull out, so basically it's like pulling marbles out of a bag. Well, there's 225 of them that I'm interested in out of the 900. And then when I pull it out, there'll be 224 that I'm interested in. And now there's 675 that I'm not interested in out of the 898. So the first 2 were over and the last one was under. Well, what if the middle guy was under and the first and the third one were over? Well, it would look like this. But you know what? What if the first one was under and the other 2 were over? The probability would look like this. So what happens is you'll notice the numerators are all the same, just different order, same as the denominators. If I take this first one and multiply it by 3, because it could happen 3 ways, and multiply it all together, I find the probability. Now, you can also use combinations. If you think about it, how many different ways can I choose the 2? Well, 225 choose 2. And how many different ways can I choose the one that's going to be under? And then if I divide it by the number of ways I choose 3, well, I'm going to end up with the same probability, 0.1404 or 0.140, 3 significant figures. All right. Something I want to mention in the book or in the test of the marking scheme, they say that 0.14 is not exactly right. 3 significant figures, you would have to put the 0.140 in order to be giving all the figures. Anyway, thanks for watching.